Today we are mastering the geometry of circles. In this lesson, you will learn how to derive and manipulate the two primary forms of circle equations, the standard form and the general form. Understanding circles is essential for the Cambridge 9709 Pure Mathematics 1 syllabus, as these concepts frequently appear in questions involving intersections with lines, tangents, and coordinate proofs. Mastering these forms allows you to identify key properties, like the center and radius, instantly, which is a vital skill for securing top marks in your examination. Let's start with the standard form of a circle equation. The standard form of the equation of a circle is derived directly from the Pythagorean theorem, or the distance formula. For a circle with center a, b and radius r, the equation is given by x minus a squared plus y minus b squared equals r squared. If the center is at the origin 0, 0, the equation simplifies to x squared plus y squared equals r squared. The values a and b represent horizontal and vertical translations from the origin. Let's visualize this using a coordinate plane. We begin with the fundamental definition. A circle is the set of all points that are a fixed distance, known as the radius, from a central point. To find the equation of a circle, we look at any point P with coordinates x, y on the circumference. By drawing a right-angled triangle between the center C at a comma B and the point P, we can apply the Pythagorean theorem. The horizontal distance is the difference in x coordinates, x minus a. The vertical distance is the difference in y coordinates, y minus b. Squaring these sides and setting them equal to the square of the hypotenuse, r, gives us the standard form of a circle. If the center is at the origin, 0, 0, the equation simplifies to x squared plus y squared equals r squared. Notice that a and b represent horizontal and vertical translations from the origin. Let's apply this immediately. Suppose we want to find the equation of a circle with a center at 2, -5 and a radius of 4. We substitute these values directly into our standard form. Notice the sign change for the y-coordinate. Because the formula uses y minus b, subtracting a -5 becomes y plus 5. This results in x minus 2 squared plus y plus 5 squared equals 16. This is the standard form. In a Cambridge exam, if the question asks for the equation of the circle and does not specify the form, leaving it in the standard form is perfectly acceptable and often safer than expanding it. Often in the 9709 syllabus, you will encounter the general or expanded form of a circle equation. This form arises when we expand the brackets of the standard form. However, to find the center and radius from this version, we must reverse the process by completing the square for both x and y. We group the terms and move the constant to the right. To complete the square, we add the square of half the coefficient of x and half the coefficient of y to both sides. This simplifies to x plus g squared plus y plus f squared equals g squared plus f squared minus c. Comparing this to our standard form, we identify the center as -g, -f, and the radius r as the square root of g squared plus f squared minus c. A crucial exam observation. For a real circle to exist, the expression under the square root must be greater than 0. If it is not, no such circle exists in the real plane. Let's look at how to convert from general form to standard form with a specific problem. Find the center and radius of the circle given by the equation x squared plus y squared minus 6x plus 8y plus 9 equals 0. Step 1. Group the x terms together and the y terms together, and move the constant 9 to the right-hand side. Step 2. Complete the square. For the x terms, take half of -6, which is -3, and square it to get 9. For the y terms, take half of 8, which is 4, and square it to get 16. Add both 9 and 16 to both sides of the equation. Now, write the left side as perfect squares and simplify the right side. Step 3. Identify the parameters. Center AB is 3, -4. Radius r is the square root of 16, which is 4. Let's visualize this. Here is the coordinate plane. We plot the center at 3, -4, and draw the circle with a radius of 4 units. A dashed line shows the radius r equals 4. By completing the square, we have transformed an abstract algebraic expression into a clear geometric picture. Let's apply our knowledge to a Cambridge-style question. The line y equals x plus 4 is a tangent to a circle with center 3, 1. Find the equation of the circle. We are given the center at 3, 1, and the tangent line y equals x plus 4. To find the equation, we need the radius. Since the line is a tangent, the radius is the perpendicular distance from the center, 3, 1, to the line. First, let's rearrange the line equation to x minus y plus 4 equals 0. Recall the perpendicular distance formula. D equals the absolute value of ax1 plus by1 plus c, all over the square root of a squared plus b squared. Using this formula, the radius r equals the absolute value of 1 times 3 plus negative 1 times 1 plus 4 divided by the square root of 1 squared plus negative 1 squared. Simplifying the numerator, 3 minus 1 plus 4 gives us 6. The denominator is the square root of 2, so the radius is 6 over root 2, which simplifies to 3 root 2. Now we use the standard form x minus a squared plus y minus b squared equals r squared. Substituting our center 3, 1, and our radius 3 root 2, we get x minus 3 squared plus y minus 1 squared equals 3 root 2 squared. Calculating the radius squared, 9 times 2 is 18. The final equation is x minus 3 squared plus y minus 1 squared equals 18. This method is highly efficient. An alternative, substituting y equals x plus 4 into the circle equation and setting the discriminant to 0, is far more time-consuming and prone to algebraic errors. In Cambridge examinations, small errors often lead to a significant loss of marks. Let's look at how to avoid them. The first mistake is sign errors in the center. Consider this equation. Notice that the signs of the coordinates are the opposite of the signs in the brackets. Students often write the center as positive 3, negative 4, because they see those numbers in the equation. Always remember the formula is x minus a, so a positive in the bracket means the coordinate is negative. The second mistake is forgetting to square the radius. When identifying the radius from an equation, students frequently forget to take the square root of the constant on the right-hand side. Conversely, when writing an equation, they often forget to square the radius. The third mistake occurs during completing the square. When adding a value to the left side to complete the square, you must add the exact same value to the right side to keep the equation balanced. Missing this step is a very common cause of incorrect radius calculations. Finally, ensure you check the existence of the circle. If an algebraic manipulation results in a negative number for r squared, the question may be testing your ability to identify that no real circle exists. When tackling coordinate geometry in Pure Mathematics 1, keep these examination tips in mind. First, always sketch the problem. A quick sketch can help you visualize the relationship between the circle, the center, and any lines or tangents mentioned. It often reveals the most efficient geometric path to the solution. Second, understand the mark scheme. Examiners award M marks for method and A marks for accuracy. Even if you make an arithmetic error, you can still gain full method marks if you clearly show a valid strategy, such as completing the square or using the perpendicular distance formula. Third, use symmetry. If a circle passes through 2 points, the center must lie on the perpendicular bisector of the chord joining those points. This is a very common shortcut in 9709 exams that can save you from solving complex simultaneous equations. Finally, watch for exact values. If the radius involves a square root, keep it in surd form until the final step. Rounding too early, for example, using 1.41 instead of the square root of 2 will lead to inaccurate final answers and lost marks. Now it is your turn to practice. Please pause the video and attempt these 3 questions before we go through the solutions. Easy. Find the center and radius of the circle x plus 5 squared plus y minus 7 squared equals 49. Medium. Write the equation x squared plus y squared plus 10 times minus 4y plus 13 equals 0 in standard form, and state the center and radius. Hard. A circle has center 2, 3, and passes through the point 5, -1. Find its equation and determine if the point 6 lies inside, on, or outside the circle. Please pause now. Let's look at the solutions. For the easy question, we look directly at the standard form. The center is the opposite signs of the values in the brackets, giving us -5, 7. The radius is the square root of 49, which is 7. For the medium question, we group the terms x squared plus 10 times and y squared minus 4y. We move 13 to the right to get -13. Completing the square, half of 10 is 5, squared is 25. Half of -4 is -2, squared is 4. Add 25 and 4 to both sides. X plus 5 squared plus y minus 2 squared equals 16. The center is -5, 2, and the radius is 4. For the hard question, first calculate the radius using the distance between 2, 3, and 5, -1. R squared equals 3 squared plus -4 squared, which is 9 plus 16, resulting in 25. So R is 5. The equation is x minus 2 squared plus y minus 3 squared equals 25. To check the point 6, find its distance from the center, 2, 3. Distance squared equals 4 squared plus 3 squared, which is 16 plus 9, equaling 25. Since the distance squared equals r squared, the point 6 lies exactly on the circle. To conclude today's lesson, here are the key takeaways. First, the standard form shows the center and radius directly. Second, we use completing the square to convert general form to standard form. Finally, a point lies on the circle if its distance from the center equals the radius. To summarize today's lesson on circle equations, first, the standard form of a circle is derived from the Pythagorean theorem. This form is your primary tool for immediately identifying the center at a comma B and the radius r. Second, the general form is an expanded version of the standard form. You must be proficient in completing the square for both x and y terms to convert this back into standard form. Third, always pay attention to signs and squares. The center coordinates use the opposite signs found within the brackets, and the constant on the right-hand side is the square of the radius. Finally, in a Cambridge 9709 exam context, geometry often simplifies algebra. Use the perpendicular distance from the center to a tangent to find the radius, and always consider sketches or properties of chords to save time.